All right, so we introduced factoring by finding the greatest common factor when we had just 2 or 3 terms. In this lesson, we'll use the distributive property to help us factor expressions with 4 or more terms. This is called factoring by grouping. And truthfully, it's a little bit like a reverse FOIL. So let's demonstrate. Let's say we were told to factor this set of 4 numbers. So this is called factoring by grouping because what we'll do is we'll group them into 2 pairs. So these parentheses are just a way of us saying, okay, let's look at these 2 individually, and let's look at these 2 individually. So we're going to ignore that second half and just say, all right, what is the greatest common factor between 4QR and 8R? You think, okay, what number can go evenly to 4 and 8? Well, that would be 4. And they don't both have a Q, so we can't pull that out. But they both do have an R, so we can pull that out. So then 4 divided by 4 is 1, so there's no coefficient here. We pulled away the R, so basically the 4 is gone, the R is gone. All that's left is Q in front. 8 divided by 4 is 2, and then we took away the R, so it's gone, leaving just the 2, because remember, 8 divided by 4 is 2. So we got that one factored. Now let's look at this one. These don't have any variables in common, so we can just look at the numbers. 3 is the biggest number that we could pull out of both of those, so we do. 3 divided by 3 is 1, so there's no coefficient there. 6 divided by 3 is 2. Then if you notice, what we have here and here are identical. So Q plus 2 is present in both terms. That means if we look at it instead of the 4 pieces, we look at it as piece 1 and piece 2. We look at it as 2 pieces. This makes Q plus 2 the new greatest common factor. So we can factor it out, say, all right, let's bring Q plus 2 out of here. That leaves 4R plus 3. So we end up with Q plus 2, because we pulled that out of both pieces, times 4R plus 3. And you can confirm that we got the right answer by foiling our answer and seeing if it's what we started with. So first, Q times 4R is 4QR. Q times 3 is 3Q. 2 times 4R is 8R. 2 times 3 is 6. And if you look, it is identical. Now the 2 middle terms are in a different order, but we're adding, so it doesn't matter. You can see we've got 4QR, 8R, 3Q. They both end in 6. Okay, so let's do the same thing here. We'll factor this into 2 pieces. Okay, one thing I need to tell you here. Whenever there's a minus between the 2 pieces, actually I'm going the wrong route, so let me back up. So sometimes, let's just go ahead and fill this out. Sometimes you'll have to rearrange the terms. Sometimes you'll have to rearrange the terms. And let me show you what kind of should have given me the hint sooner than I need to. What do these 2 pieces have in common? Nothing. 2 and 15 don't have anything that go into both of them. This is the only piece with variables. This has none, so that would be no good. So instead, we say, okay, what would make more sense to pair with the 2? Well, it seems like the 6 would be good because it has u squared, and 2 and 6 are both even, so we will be able to factor in a number also. So 2u squared v, then keep the minus sign, minus 6u squared, and we'll put the 5v next and the 15 last. In general, stuff that has more variables, and I'm just talking about the pairs, just like look at these 2, the stuff with more variables tends to go first. The stuff with these 2, the stuff with more variables tends to go first. So now we can group them in pairs. These are both have 2 in common. They both have u squared in common. So I took away the 2 and the u squared, leaving a v. 6 divided by 2 is 3, but I took away the u squared, so it's just 3 left over. These two just have a number in common, that would be 5. Take away the 5, left with v. 15 divided by 5 is 3. So just like happened on the first example, now we have v minus 3 in both of these. So we're going to factor out v minus 3 from both of them, meaning just like I took 2 and u squared and was one with v, I'm taking the v minus 3 out. I'm just left with 2u squared plus, take this v minus 3 out too, and left with 5. Now you don't have to FOIL this to test your answer, but if you want to, you can. Okay, next up, factor rn plus 5n minus r minus 5. Okay, this one's fine in the order it is, but here's another note. Let me go ahead and draw this. So you see right here, my first term is a negative. So in order to avoid causing problems, we need to factor a negative 1 out of these two. So I'm going to write rn plus 5n plus negative 1 times positive r plus 5. I could also just write that as a minus 1. But the point is, I want to change these signs so that I don't have a negative variable to start on the inside. So if the first term in a group is negative, you'll need to factor negative 1 out of that group. Okay? So rn plus 5n, they both have an n in common, so I pull out n. That leaves r in the first term and 5 in the second term. Oh, and actually, this one, it's already done. If you look, there's nothing to factor out, but it's already r plus 5. So we can pull r plus 5 out front. That takes this away, leaving n minus 1. So our final answer is r plus 5 times n minus 1. Okay, now here we hit that issue again where if we look at the first two, they have nothing in common. Nothing goes into both 4 and 21. This has variables, this does not. So it looks like this would be paired better with this, because we have 4 and 12 have a common number, and b squared they also have in common. So let's put those two together. And again, this one has a variable, this one doesn't, so I'm going to put the variable one first. So now we can pair them. 4 and 12 can both be divided by 4. This has an a, but this doesn't, so I'll just have to leave that a. But they both have b squared, so I can pull that out. So here, the 4 was taken out, the b squared was taken out, leaving just a. 12 divided by 4 is 3, and the b squared was taken out, so we're just left with that. These two just have a number in common. They're both divisible by 7, so I pull a 7 out. That leaves just the a right there. 21 divided by 7 is 3. And just like the good work we've been doing, we see we have the same term in both of them, a plus 3. So I pull a plus 3 out front, leaving 4b squared plus 7. Oh, and one thing I should note, if it's ever multiple choice or you're checking just the back of the book or the answers I show on the board, it doesn't actually matter what order I put these in. I could say 4b squared plus 7 times a plus 3. That answer is just as correct because we're multiplying, so it doesn't matter which term comes first. Okay, let's pair these up. 2mk and 12m. 2 they both have in common, and they both have an m. So 2 and m are taken away, leaving just the k. 12 divided by 2 is 6, and they took the m away, so that's all that's left. Okay, 42 and 7k have a 7 in common. 42 divided by 7 is 6. 7 divided by 7 is 1, so we just get 1k. This is weird. It's almost like they match, but not quite, because we have a k minus 6 and a 6 minus k. So here's the trick. If one term seems backwards, switch the location of the two terms, meaning change it to negative k plus 6, but that still doesn't match, so then you have to factor out a negative 1. Because if we factor out a negative here, that goes from a negative k to a positive k, and a positive 6 to a negative 6. And now they match. So if it seems like the terms are similar, but one's backwards of the other, just flip which side they're on, just switch their locations, and factor out a negative 1. Now they both have k minus 6. And when we take those out, what's left is 2m minus 7.